All right, happy cereal day. Every March 7th is cereal day. Yeah, happy birthday, Jenna Fisher and Brian Cranston and Marcus Aurelius. Um, took the throne with his stepbrother. Joint rule 161, kind of at the end of the Pax Romana there. Anyway, Marcus Aurelius, a very, very important figure, not only in Roman history, but in Stoic philosophy. Great Stoic philosopher. You can summarize his entire philosophy by do your math homework. That's kind of Marcus Aurelius's theme. Okay, an amount A increases at a rate proportional to its current amount. Hey, if we just read that right there, would that ring any bells? An amount A increases at a rate that's proportional to its current amount. Yeah. In fact, it says such that, that's what we would have written, right? Such that dA dt, the rate of change of that amount, is equal to K times A. So in this case, you were given the relation between them, but you're not always given that. It says where T is measured in hours. If the amount triples every 11 hours, find the value of K. Find the value of K. So do you remember from last time, there's a short, quick, fast way to do it. If you know it's going to be dA equals dt equals Ka, that is going to be strictly exponential. And what would the solution be? Instead of y equals, it's A equals CE to the KT power, right? That's the general solution. And then you either create two ordered pairs and plug them in to find K, or you remember that K is equal to the natural log of the scale factor, right? Whatever it was, divided by the time for the scale factor to occur. So if you remember that, and you don't have to, but it's a big time saver. In this case, K would equal the natural log of what? Perfect, boom, and there it is. And if you want the decimal, it says to find the decimal, you can just type it into your calculator. I'm not going to do that. Okay, there it is. Now, let's say you forgot that. You're like, oh crap, I don't know if it was a natural log 11 over 3 or natural log 3 over 11. You would create two ordered pairs. You would say, okay, T and A. So my first one would be 0. And we don't know what the initial amount was, do we? Does it matter? No. So if it doesn't give you, you specify a 1, right? And then if it triples every 11 hours, here's what's important. 11 hours later, it's going to be 3 times whatever you started it off as. So 3 times 1 is 3. And then you just plug these 2 points in one at a time and solve for K, right? So we did that Friday up here at first, all right? So that right there could be a nice multiple choice question. All right, if you want to write the model, since now we know K and we know that the initial value could be 1, well, you'd be given the value if you were to actually write the model. So I'll just skip that right here. Let's look at example 9 now. These are kind of starting to get into actual AP questions here. The weight of a population of bacteria. Ooh, that's a strange way to measure bacteria, right? Went to the store the other day and picked up 5 pounds of bacteria. Given by the differentiable function b, where b of t is measured in tons. Holy crap. And t is measured in hours. That's a ton of bacteria. The weight of the bacteria population increases according to the equation dBdt equals k times b, where k is a constant. So one of the things with this type of differential equation is you have to be able to recognize it either from the verbal description, like up here, right? A increases at a rate proportional to its current amount. That's the giveaway wording. And or you recognize it from the differential equation, which is dy dt equals k times y, or dA dt equals k times a, or in this case, dB dt equals k times b. B for Ben delay, right? Yes. B for bad Ben delay, skipping. No, you deserved it. You were with your family after the, yeah. Yes, sir. Yes. Yeah, outside, it was a beautiful day. Yes, sir. Yeah. But grandparents were there. That's good. They could all take the test in here in 40 minutes anyway. They didn't need that extra 20 minutes. Yeah, no, they're smart. At t equals 0, the weight is 3 tons. At t equals 0, the weight is 3 tons. So now they're actually giving us an amount, and it's increasing at a rate of 2/5 tons per hour. What is an expression for B? Ooh, okay. Well, let's do this. Let's go straight to the general solution. If dB dt equals k times b, then b must equal what? Sect, right? The sect equation. KT are the exponents. Now, do we know, you could write this as B or B of T if you want. I'll go ahead and put B of T. Do we know what C is? Remember, C is your initial amount, right? And by initial, we mean it corresponds with 0. It's the y-intercept. So it's 3. So it's 3e to the kt. And now we just need to figure out what k is. Can we figure that out? Yes. It's increasing at a rate, bless you, of 2/5 tons per hour. So k should equal the what? The natural log of 0.4? Yeah, or 2/5 or 0.4, either one. Over what? 1. Right. There you go. So here would be the final equation. B of t equals 3 times e to the natural log of 2/5 or 0.4, and that's a coefficient. So I'm going to do it like that. And there's the answer. So we can set it up pretty easily. Now, let's do one last thing here. If this were a multiple choice question, that might be an answer choice. But let's say that you preview your answer choices and none of them are in terms of E. What do? Well, you manipulate it, right? If I wanted to, I could bring this T in the exponent. I could bring it in the front, can't I? Yeah, that's just multiplication. And now that it's in front of a natural log, why boy howdy, I could bring it up as an exponent on the argument, right? And that becomes 3e to the natural log of 2/3 to the teeth power. And oh, look at this. What is e to the natural log of blob? It's the blob. So that goes away and jumps down onto the ground floor. And that's an equivalent version of it right there. 3 times 2/3 to the teeth power. 2/5. Yeah. How did I get thirds? Oh, because I can't read my own writing. Yep. Yep. Yeah, it is a big deal. Yeah. Thank you, Mason. See, it pays to sit in that front row seat there. Get the best view in the house. So any exponential function can be written in terms of e simply by going backwards, writing the original base as e to the natural log of that base. Okay. So when we set it up in this format, when it's in this format, it has to be in the exponential base e form. But if you wanted to use it, it might be worth simplifying before you use it. Okay. So there you go. There's that one. Bless you. This one here, I'm going to skip this one. This is more of like a pre-cal question. Okay. But it's a nice application, right? Radioactive decay. Suppose that oil's pumped. Yeah, that's pre-cal. Suppose, yeah, that's pre-cal. Let's jump down to example 13. This is an actual question from an AP exam. 2012, this is question 5, no calculator. So you're almost 4 hours into the test and you get into this and you're like, oh, a baby bird, and then you perk up, right? He's like, oh, I like baby birds. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. Is that strictly exponential? No. If it were strictly exponential, it would say the rate at which a baby bird gains weight is proportional to its current weight. That's it. But it's proportional to the difference between its adult weight and its current weight. Okay, all right. At t equals 0, when the bird is first weighed, it weighs 20 grams. Okay, so there's an initial condition. If B of t is the weight of the bird in grams at t days, so those are our units, after it's first weighed, then, and look, they're giving us the differential equation. Oh, okay, thanks. dB dt equals 1/5 100 minus b. That's the differential equation. Let y equals b of t be the solution to the differential equation above with this initial condition. All right, we'll let that happen. No objections from me. Part A, is the bird gaining weight faster when it's 40 or when it's 70? Explain your reasoning. Is the bird gaining weight faster when it weighs 40 or 70? Well, the wrong answer would be when it's 40 pounds, because that's when it weighs less and it has more weight to gain, right? That's not real good reasoning. How do we figure this out? What are we trying to compare? The slope of B, right? So for the slope of b, I need the derivative of b, don't I? Do I have the derivative of b? Boy, howdy, it's right there. And look at that. It's in terms of the bird's weight, which we're given. Holy moly smokers. So here's what I would show. dB dt at b equals 40, like this, equals 1/5 of, I don't have to show 100 minus 40. I can do that in my head. That's 60. And then 60 divided by 5, that's 12. And now what are the units? Units of B over units of T. That's going to be grams per day. Okay. So in other words, when it's 40 grams, it's gaining 12 grams per day. And then similarly, dB dt at B equals 60 or 70, sorry. You get 1/5 of 100 minus 70, which is 30. And that's going to be 6 grams per day. All right. Did we answer the question? Do we walk away? No. Now we got to answer the freaking question, right? So the bird gains faster. You can say wait if you want. When it's, and that's a good use of a pronoun, right? When I say it's there, does everyone see the antecedent? Some people on the test, we'll go over tomorrow. Some people were saying it, you know, and I wrote, what is it? But in this case, it's the bird. When it is 40 grams. Do I stop there? Does that answer it? It says to explain your reasoning. Comma, since what? What's the linchpin? 12, yeah, but why is 12 relevant compared to the other one? Since that's it. That's all. Yeah, that's it. That's your reasoning, right? 12 is a bigger number than 6. That's it. Okay. There you go. There you go. All right. Comments or questions on that one? Fastest. Yeah. Yeah. Sorry. Fastest. There you go. Yeah. No, keep me honest. And that's a G and then a comma. That looks like a G. All right. Find d squared b dt squared in terms of b. Okay. There's two important things in that short little sentence. First of all, this means to find the what? That's the same thing as b double prime of t, but it says in terms of b. All right. That means there can only be, if any variables, it has to be in it. All right. So I'm going to come over here and rewrite dB dt. It was equal to 1/5 of 100 minus b. All right. Now I'm going to take the derivative of both sides with respect to t. And how do I show it? d dt colon, right? All right. So what's the derivative of the left? Well, it's d squared b over dt squared. 1/5 goes along for the ride. So you could do 1/5 beefy bracket. I like to put the beefy bracket, keeps the constant multiples from sneaking in, you know, because, you know, it's more fortified. No, you stay out front. All right, now we're finding the derivative with respect to t. So what would the derivative of 100 with respect to t be? 0. I'll go ahead and write it down. Minus, what would be the derivative of b with respect to t? Is it 1? It's 1 times the chain rule, dB dt, right? What throws people off on these types of questions is your differential equation is a function of the dependent variable, right? Not the independent variable. If that were 100 minus t, then you could say the derivative would be 1, because that's what dt is, right? So always kind of throw that in there. What would be the derivative of b with respect to t? dB dt. Oh, it's dB dt. Do I stop right there, walk away? I got the, no. Well, that would get a derivative check right there. But now it says to do it in terms of b, and I have it in terms of dB dt. So let's see, I can pull the negative up front and call it negative 1/5. And then how am I gonna, what is dB dt in terms of b? Oh, I'll just substitute it right back in, right? dB dt is this, right? Oh my gosh. So that's gonna, boy howdy. Have y'all used that outside this class? Y'all get looks? All right. Boy howdy. Boy howdy. You should try it. You should try it. All right, there it is. That would get the credit. You wouldn't have to simplify. But look what it says. It says, now use it. You're like, if I'm going to use it, I probably want to simplify it. That's where they get you. Now, sometimes you could actually lock in your point right there. So if you accidentally call that like -1/10, you wouldn't lose the check that you earn on the line above, right? But it's -1/25 times 100 minus B. Understand what variables are independent variables and what are dependent variables. All right, use it to explain why the graph of B cannot resemble the following graph. Oh, so there's that graph. It looks kind of like a what kind of graph? Logistic. It looks like a logistic. Now it says to use your second derivative to say why it can't resemble this. So yes, thank you. The second derivative gives you what information? This is B of t right here, and this is t. This is them saying, hey, I hope you know what the second derivative gives you in terms of the original function graphically. It's concavity, right? So we have to look for some kind of concavity argument. So what do you notice about this function here? It starts concave up, and then it turns to concave down. So there's an inflection point in there. But the second derivative is positive at first from 20 to something, and then it's negative from something to 100. Does that sit well with this equation? No, because notice for values of B, and again, this is your dependent variable. For values of the bird's weight from 20 to 100, what do we know about the sign of this if you plug in a value between 20 and 100 non-inclusively for B? It's going to be negative, right? 100 minus 20 is positive times the negative is negative. 100 minus 99 is positive times the negative is negative. There you go. The actual graph, according to our second derivative, should be concave down exclusively from 20 to 99 or 20 to B or 100. So let's go ahead and say something to this effect, right? D squared B over dt squared is going to be less than 0 for all B on the interval from 20 to 100. So the solution, or actually just, you could just say, so B of t. So B of t should be concave down on this interval. You can say that again. Is that enough to stop there? Comma or semicolon, however, comma, the given graph is both concave up and concave down, or just is concave up on this interval. That's probably the fastest way, is concave up on a portion of this interval. So that's a lot of words, right? We're writing a lot of words. It seems like an essay, but notice it says to explain. And whenever it says to explain rather than justify, that's typically meaning you're going to have to use some English words there. Something to that effect. Something that compares the curvature of the two things, the equation, which implies concave down everywhere, to the graph that has a portion that's concave up. And again, realize that our function is in terms of B, the dependent variable, not the independent variable. And that's what kind of screws people up on part C as well. All right, so far so good. Little birdie question. All right, part C, use the separation of variables. That's why it's in this section, to find the actual equation of y equals B of t, the particular solution with this initial condition. All right, before I can find a particular solution, I have to find the general solution. Yeah. So let's go ahead and bring the, this is going to be worth like at least 5 points, greater than or equal to out of 9. So dB dt equals 1/5 times 100 minus B. Here's what a lot of students did. I didn't grade this question this year, but I looked it up, and here's what a lot of people did. They went, okay, So the antiderivative of db dt, which is really b prime, is just b of t, and 1/5 goes along for the ride. So this becomes 100b minus 1/2 b squared. Boom, I'm rolling, I'm rolling, I'm rolling, right? The antiderivative of the derivative is the function, and I just power rule, baby, power rule. Does that work? No, 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 no. That would work if this b up top were a what? A t, because that's your independent variable. And guess what? It isn't. Okay, so that's why it said to use the separation of variables. So that's kind of like a kind of a heads up, right? So this is not good. If you did that, you're like, you don't even get, you lost all 5 points right out of the box, right? I don't want to do that. So let's separate the variables. The 1/5, he's cool to stay on the right-hand side, right? He's a constant multiple. That's where everything's going to end up anyway. Let's multiply both sides by dt and see if that does the trick. I'm just kind of curious. 100 minus b dt. Does that separate it? B's and db's on the left and constants and t's and dt's on? No, 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 no. Should I distribute the 1/5? Should I distribute the dt? No, no, no. Because all the separation has to come from is multiplication and division. So I want it to be factored. So I'm going to divide both sides by 100 minus b. And if you do it on the left, if you actually show it on the left, like on the free response, make sure you show it on the right or vice versa. Show it on the right, show it on the left. And now what happens on the right-hand side? Those divide out. So you're left with 1 over 100 minus b db. That's a good way to write it. Equals 1/5 dt. Did that get to the separation? Yes. So now you got your first check. Oh my gosh, algebra on this part, on part C. You've already got checks above for sure. All right, so now that we've separated the variables, now we sneak in the slinky, slithery integral symbol, right? All right, so here we go. It's just like two separate problems now. The left side's with respect to b, the right side's with respect to t. If you want to, could you bring this whole thing to the top? Sure. This is 100 minus b to the negative first, right? I'm focusing on the left. So now that forces you to put parentheses. So the outside function could be blob to the negative first, and the inside function could be 100 minus b. That's your blob. What is the derivative of 100 minus b? With respect to b? What's the derivative of 100 minus b? Well, 100 goes to 0. What's the derivative of minus b? -1. Does a negative really matter? Oh, yes, it does. Hugely, hugely. The derivative of this is -1. Do I have a -1 in the top? No, I'm off by a -1, so I have to have a correction of a -1. Oh, a lot of people miss that. Okay, and now that I've made my correction and I've verified on the outside, now what's the antiderivative of blob to the negative first? Natural log of the absolute value of 100 minus b. Yeah, we don't need a plus c over there. If that were b minus 100, then there would be no correction, but it's 100 minus b. I think if it had been like 100 minus 2b, most of y'all would have said, oh, we're off by a -2. But sometimes that little negative, he could just be so innocuous and sneaky, little spy. He's out to destroy you. Now notice I've worked at what? Perhaps, right. Vladimir Putin. Hey, that reminds me of a joke I heard. What did the constipated Russian say when he was on the toilet? I'm Russian. Glad to be pooping. Yeah, glad to be pooping. Yeah, glad to be Putin. I guess you can say Putin too. That works. All right. Now notice I've worked down on the left. Potty joke. Sorry. I'm only 48. Sorry. Working straight down the left-hand side. I got to now keep the equality going, don't I? So on the right-hand side, what would the antiderivative of 1/5 be with respect to t? 1/5 t, which is probably a check, and then plus c, which is another check. And of course, this is a check. So now it's a point party. All right. And now I just got to bring this down because it took one extra line on the other side. So make sure you keep your equalities going. All right. So now I need to solve for what? B? For b, right? Boy, that's going to be fun, isn't it? solving for B. Well, first of all, let's multiply both sides by -1, okay? So I get the natural log of 100 minus B. And if I distribute on the right, I get -1/5 t and then minus C. But guess what? ShamWow C. Boom. -1 times C is positive C. How do I unnatural log both sides? I E it. Now you could actually show it like that if you want, so that both sides become exponents. E to the natural log of blob is the blob. We still keep the absolute values there, remember? And now over here, I can either keep the whole thing in the exponent or use our little trick, right? Yeah, that becomes e to the -1/5 t times e to the cth power. We've seen this so many times now. By so many times, I mean like twice, maybe 3 times. But it will, yeah. And now e to the c is ShamWow c, which is multiplied instead of added. So I can put it in the front, e to the -1/5 t. And now because I have an unknown constant in the front to absorb the plus or minus, can I drop the absolute values now on the left? Yes, now I can. All right. Now I just got to solve for B carefully. Wow. You want to subtract 100 from both sides? Negative B equals CE to the -1/5 t minus 100. And we're almost there, folks. We're almost there. Multiply both sides by what? -1. Now, when I multiply the first term on the left by -1, can C absorb the -1? Am I still in the process of solving? Yes, I can. In fact, I'm going to, well, let's not put it up T yet. Let's just say B equals C times -1 is ShamWow C. But can the -100 just absorb the negative and stay negative? No, he becomes 100. Okay. Now there it is. I solved. So if you want, you could step up the notation. It's not a requirement, but you could call it B of T. This is your general solution. All right. Now we need to find the initial condition using the point 020. Notation, 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 right? So we'll say at 020, you get 20 equals C times e to the 0th plus 100. So that's C, right? So if I subtract 100, what's 20 minus 100? -80. You're going to get a check right up here for simply using C. Like if you have the wrong equation, but you use C by plugging it in, you're going to get the check more than likely. And now we say, so, and then you plug this back into the general solution. So B of T, in this case, the baby bird's weight is going to be -80 e to the -1/5 t plus 100 on the ground floor. And you don't even have to box it, it's your bottom line. So it is modified exponential. We can actually sketch that. Let's review. Our parent function is e to the t. Okay, it's in standard transformation form. What does the negative do in front of it? Reflects it across the x-axis. That's what the negative does. What does the 80 do? Just makes it steeper, right? So it's the same shape. And then going inside, what does the negative in front of the t do? Flips it across the y-axis. Yeah. So now it looks like this. And the 1/5, is that a horizontal stretch by a factor of 5 or a horizontal compression? Stretch, it's opposite. So it's 5 times wider. So it just has the same shape. And now what does the plus 100 do? Moves it up 100. So the horizontal asymptote, which was at 0, is now up here at 100. And it looks like this. And it's modified. It looks like this. So it's a modified. It's probably only going to be good from right here. We can't extrapolate the baby bird's backward weight to like a negative weight. But for values of t greater than 0, this would be grams, and this will be in time in what are we units? Days. Yeah. Okay. Good. Days. And just looking at it on the interval from t to infinity, that's how long the bird's going to live, I guess. Is that concave down everywhere over that interval? Yeah, that's what we said earlier, right? It had to be. So this bird is going to live forever and get closer and closer to 100 grams, which is pretty typical for that species of bird. 100 grams. What kind of bird was it? Bluebird. This is a bluebird, a baby bird. Baby birds, yeah. All right. So how would y'all have done had this been a test question? The average was kind of low. You want to look it up? 2012 question 5. 2012 question 5. Let's see if I can get Siri. Siri, oh Siri. No, here we'll do this. 2012 AP calculus. And we look up scoring guidelines. Let's see if this was a joint question. All right, here it is. Yeah, here it is. So let's see how we would have done. Let's see where the points came from. This was a question that was on both A, B, and BC. You got one check for using the BDT, and look at that. It says for using it. You could have plugged in, like, instead of a 40, or you could have plugged a fork into it and gotten a, yeah. And then one point for the answer with the reason. Part B, 1 point for the second derivative in terms of B and 1 point for the explanation. Let's see, theirs was a little more concise. Therefore, the graph of B is concave down for 20 to 100. A portion of the given graph is concave up. See, yeah, whatever. And then look at this one. Look at the big, wow, look at 5 points. 1 point for the separation. We got it. 1 point for both antiderivatives. We got them. 1 point for putting the plus C right there on line 3. Okay. 1 point for using the initial condition, for plugging it in, and then 1 point for solving for B. And then look what it says here at the end. Note, no soup for you if you don't show the separation of variables. Yeah, 0. So got to show. Yeah. Now let's look at not just the scoring guidelines. Let's look up the scoring statistics. Let's see. Is it AB? Is that the scoring? Okay. What question was that? 5? Well, actually, this is oh, thank you. Thank you. Let's look up, let's look this one. There you go. Yeah. So this is AB. Y'all's was a little bit higher because y'all's had they had a split question in there on one of them. So I didn't know what numbers it was, but here there's 6 questions, right? Look at number 5. That's the baby bird. So the average AB student got less than 3 points. And if you look at the averages here, the average is around, it hangs around a 3, right? Question 4, which the average student got 4 points instead of 3. That must have been like a gimme, right? They must have just been handing those points out at the door. Are you expected to get a 9 in order to pass? No. If you can muster like 60%, you're going to pass with a 3. Yeah, 60 easily. Yeah, easily. So don't try to live up to the standard of perfection. Okay. You aim for that, but you know, if you fall short, you're good. All right. We're done with 5.1. Okay. Very, very important in here is the separation portion and also the special differential equation right here. dy dt equals k times y. Go straight to y equals sec. Yeah, we're done. Okay. Tomorrow we're going to do 5.2, or yeah, 5.2 is tomorrow. That's going to be slope fields and the review session. Now, Landon's already done a slope fields review session outside of class, but not everybody attended. So tomorrow I am going to move through that section. I'm going to hope to do it in one day. I'm going to hope to do slope fields in one day. We are going to go over the test tomorrow. I'm going to hope for it. We'll see. Yeah. No. I might give back the test tomorrow, but I might not go over it tomorrow. Okay. Yes. 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 Okay. Um, but yeah, I will try my darndest to use as much time as I can tomorrow to finish 5.2 in one day. Okay. All right. You'll have the rest of this class to work on, do some of the worksheet problems from this section. Remember, it's optional. If you haven't done any of your AP classrooms, they're all open. Every single one of them is open now. So you got some work to do. Use your time wisely. We don't get free time in BC very often.